Welcome to HVAC and Refrigeration Fundamentals, a primer for the Mechanical HVAC PE exam. I'm Dan Malloy. Let's start with a course overview. This course is broken up into 4 sections: thermodynamics, fluid mechanics, heat transfer, and HVAC. Thermo, fluids, and heat transfer make up 15 to 20% each, and HVAC makes up 50%. We should spend as much time as possible on HVAC, but this course is a primer, and we need to have a solid foundation first. Now let's take a closer look at each section. For thermodynamics, we'll define the main properties of substances. These are terms that the rest of the course relies upon. Then we'll look at the steam tables and describe when and how to use them. Next, we'll introduce ideal gases, their properties, and the types of processes they undergo. Lastly, we'll cover the first law of thermodynamics and how it can be applied to open and closed systems. For fluids, we'll start off by describing laminar and turbulent flow. Then we'll walk through the calculation for friction loss using the Darcy equation. Next, we'll talk about pumps and how to calculate hydraulic horsepower and efficiency and how to prevent cavitation. Finally, we'll discuss how to analyze pumping systems based on common setups you're likely to encounter. For heat transfer, we'll define conduction, convection, and radiation, including the distinction between natural and forced convection. Next, we'll introduce the overall heat transfer coefficient, which allows us to deal with 2 or more of these heat transfer mechanisms at once. Lastly, we'll explore heat exchangers with a comparison of parallel flow and counterflow to show how the analysis differs. Then we get to HVAC, the meat and potatoes of this course. Our first topic is refrigeration cycles. We'll break down the cycle in detail, drawing the process schematically and on the pH diagram. Next, we'll talk about chilled water systems. We'll make clear the distinction between chilled water and condenser water and show how they both interact with a water-cooled chiller. We'll go over how cooling towers work, and we'll discuss water-side economization. No course on HVAC would be complete without a section on psychrometrics. We'll talk through the properties of air and the processes air can undergo using the psych chart, with particular attention to process lines for air conditioning. Next, we cover cooling loads. We'll outline the process of sizing a cooling system by identifying all sources of heat. The next topic is ventilation. You need to understand the ventilation rate procedure. We'll sketch out a typical outside air handler to show how fresh air is introduced in practice. In the last section, we'll list the common types of air handling equipment and their applications. We'll wrap up with the fan affinity laws and calculating friction loss in ductwork. If you're a PE candidate taking the mechanical HVAC test, my goal for you by the end of this course is that you have a solid conceptual framework of the most important topics. Instead of feeling overwhelmed and unsure where to start, I want you to be excited to begin studying and working actual example problems. So with no further ado, let's begin. HVAC and Refrigeration Fundamentals.